All right. Last video, we discussed, I believe it was nested if statements. This time, we're going to talk about compound if statements. So if you want to make a new project, whatever today's date, name, I called it compound ifs. Now, uh, the major difference between these two, let me just go ahead and break out a nested if for you. Int var1 equals 0, int var2 equals 0. So nested if var1 equals 0, if var2 equals 0, and if, and I'll just print they are both 0. So both of them are 0. The first if will make it because that's true. It'll go inside and run whatever code is in these braces here, which is the second if. var2 is also 0, so that will be true. That'll run. And that leaves us with this one statement that pops up. Now how this works is the first statement has to be true in order for us to even check the second statement. Now as you can see, it goes from here, then I have more. And if I have, let's say, 3 or 4 things I have to check, maybe, I would have to nest another one in here. But there is actually a better way. We can use something that's called a compound if. Now, a compound if that asks the exact same question will look like this. All right. There we go. I run it, and you'll see both those statements run. If I change any single number up here, neither run because, well, var1 is false, so the rest of this doesn't run. The way a compound if works is you have if, and then you'll have a Boolean statement. var1 is it equal to 0. And in between, we can have a couple of different things. This right here is and. So I can put and, which is basically the same as saying, let me a little dash or something there. There we go. This and this both have to be true. So the way this works is if one is true, it'll go and check the other one. And if both happen to be true, this entire thing ends up being true. Now, if one of these is false, it fails. So if I change this to 1, for example, that's false, and that's false. So if you add a false and a true together, you get false. The only way for this to actually run is for both sides of this to be true. Like that. Now, I can add as many things on here as I want. I can add, var3 if there was a var3 equals 0. And var4, equals 0. As many as I'd like, really. And it will check all of these. And the and basically is basically just going to, say this one has to be true, and this one has to be true, and this one, and this one. That's what a compound if does there. Now, I could also use this symbol here, or. That way. Now, an or, and it uses what's called the pipe symbol. It's directly underneath the backspace key on most keyboards. If you hold shift, you'll see that kind of backslash key there. It's right there. And or means, if I change this to or, for example, let me show you what the difference would be. Or means either of these could be true. As long as one of them is true, this is going to run. So if I change that to 1, for example, it's still going to run because this is 0. If I change them both to 1, then that's the only time it's going to fail. Let's just copy that actually. Copy, paste, and I'll make one and, one or. So I have two. And if you want to go ahead and throw in a couple more variables and try, uh, tweaking around with it, messing around with it, by all means. Now, you may ask, well, what happens if I said this and that, or, var3 equals 0. I don't have a var3, but the way this statement would read if I wrote it this way, and it would work, both of these would have to be true because of the and. The and kind of connects these two together. Or means if that first set failed, then as long as that's true, it would run. So this is a good way to basically set it up so, if you have to check 3 or 4 things at once, you can do it with a single line. Like that. Now, if I were to, and usually they would, look like this. A lot of people will mess up and they will write, let's see here, something like this. If var1 and var2 equals 0. That's a common mistake here. And the problem with this is both sides have to be a Boolean statement. A Boolean statement has this equals equals or less than greater than, and I could use less than or greater than here instead if I wanted to. Perfectly acceptable, like that. But the issue here is both sides right here have to equate to true or false. If I take that off, your mind may think, well, what I'm saying is if var1 and var2 are both 0, but that's not what the computer is going to see. The computer is going to see if var1 and if var2 is 0. It won't see, it has to see specifically the equals 0. Now, the only place that's not true is if I have a Boolean. Check 1 equals true, Boolean check 2 equals true. And again, 1 equals is an assignment, 2 equals is a comparison. So if I were to do this, I could say, if check 1, I can write equals true. And it filled out a bunch of stuff for me here. There we go. And check 2 equals true. So I can write out this whole thing. Oh, and I should also mention this. Some people will put a semicolon at the end of this if. This ends the if effectively. So even if it's true, it's not going to run anything. That's why. And you can also do an if like this, technically, and it will run. But the problem is, without the braces, there's really no clear separation of where it starts and where it ends. If you have multiple lines that need to go in there, you're better off putting the brace in there. So I can write this, or I can get rid of the equal true, actually, and just say if check 1 and check 2. This is exactly the same thing as saying, if check 1 equals true and check 2 equals true. Those are the same statements. Now, if I wanted it to be false, I would say not. Check 1, not check 2. And I don't have anything printed. Let's see pickles. There we go. But that's a possibility too. You can use Booleans, you can use strings if I wanted to. I can say, if the password is this, I think I mentioned something like that when we went over the password checker. I could do a compound if this is this, or if this is this, or if this is this, or if this is this. That sort of thing. So, ta-da! This would be compound ifs. Now, a compound if and a nested if can do pretty much the same thing, but there are some slight differences. And that difference is this. If the first one is true, it will run whatever code is in here. And then I can check the second one. If there's other code I want to run, this will work, and it will run that extra code. Now, if I'm looking at a compound if, it will not run any code unless all of these are true. So It honestly depends on how you want to lay it out. If you want, to check the first thing and then you want to do a couple of things and then you want to check the second thing, the nested if's probably the better way to go there. If both things need to be true or false or specific things or something or within a range, then you can use the compound if. And honestly, it is significantly shorter, as you can see. This right here, this right here, especially if I had some stuff printed in there or several lines of code that we're going to run. And imagine if it was a large program where I had to do something like this, a dozen times or something like that. Or I had to check 10 different variables. If I have the key and my level is this, I think I discussed that before. Instead of making, you know, a bunch of nested if statements, I can just check it all in one line. Is this true? Is this true? Is this true? Yep, okay. The door opens, you level up, you go to the next area, you win, whatever, depending on what game or program or whatever it is you're doing. Now, if we have these compound ifs, we have true and true, that equates to true if both sides were true. This would be true. This would be if, I have, for example, a Boolean or even one of these. If that is true, then this is going to run. Now, true and false is false. Both sides have to be true. So false and true, that ends up being false. And as you can see, false and false, also false. Basically, for it to be true, everything has to be true. There's only really one possibility in that case. If we're doing the or, however, actually I can just go ahead and move that up. That makes more sense. If we're doing the or, then if it is true or true, then that's going to run. If it is true or false, that will run. Because only one of those has to be true. The other one could be false. If it's false or true, then that's true as well. The only way this fails is if it's false or false. Now there are a couple of times where uh, I would say writing your if statements, especially compound ifs, can be counterintuitive. Depends on what you're writing. I've had a lot of people who try to use compound ifs in a program and they'll be like, well, this program, this variable should be this variable should be that, and they'll use or. So if this variable is this or this variable is that, and the program doesn't run. Uh, Depending on how you're trying to write it, if both of these have to be certain numbers or within certain ranges, then you have to use the and. A good example of this would be if I had a number range. Int num1 equals, let's say, 5 or something. Int num2 equals 6. Let's use 5 too. Alright, so actually I could just use 1 for this probably. Let's just use the 1 variable. Make it less confusing. So if I say if num1 is less than or equal to 0, and what if I said or num1 is greater than or equal to 0? And it helps if I write num1 and put that brace in the right direction. There we go. Now what this actually does, it says, in this particular case, if basically, well, actually, do I want to say 0? I want to say a range. Let's say 10. Because between 0 and 10 is what I want to say here. So if it's less than or equal to 0, or if it's greater than or equal to 10. And what this is actually going to do, if I write this statement here, is num has to be less than 0. So basically, negative 0, negative 1, 2, 3, and it has to be 10 or greater. Well, actually, 0, negative 1, negative 2. Or it has to be 10, 11, 12. This is actually not going to pick the range in between. Now, if I copy this and I change this to and, Let's see how this looks. All right, so if number 1 is less than or equal to 0, and I'll flip these around here so you can kind of see what happens here in a minute. Let's say, all right, less than or equal to 0 and greater than or equal to 10. Well, this isn't possible, right? It's not going to work. And the reason this isn't going to work is because, well, it can't be less than 0 and greater than 10 at the same time. Now, if I flip this around, greater than or equal to 0, less than or equal to 10. Let's flip this here, greater than, less than. Now, and this is actually what I intended originally, but if I say this is greater than or equal to 0, or this is less than or equal to 10, what this is going to do is basically it will allow every number with this. So basically, all numbers work. Poo. Wee. So if I change this to, 100,000, I'll get poo. Actually, it doesn't really matter what number I change this to. Negative 10,000. Poo. Or 1,000. Because this is basically says if it's greater than or equal to 0, which is all the way up to infinity, well, in this case, 2.7 million or something, or if it's less than or equal to 10, which goes back the other direction into the negatives. So this is basically saying if any number is allowed. This, however, if it's greater than or equal to 0, meaning 0. Now, 1, 2, 3, 4, 5, dot, 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 right? It might help if I put a little comment there. There we go. Now, the problem is I have this and here that says num1 also has to be less than or equal to 10. Well, 0 is less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here restricts the range within these numbers, 0 to 10. So if I'm looking for a range, let's say I have a random number generator that's getting picked. And if it's between 0 and 2, it means this happens. If it's between, 3 and 5, this happens. Between 6 and 8, this happens. If it's 9 and 10, critical hit or whatever it is I'm trying to do. So that's the difference here between the and the or. And a lot of people get this a little confused. They'll throw in an or and they'll be like, why isn't it working? Well, remember, or either side can be true, not both sides. But a lot of people will look at it like, oh, well, it can be, greater than or equal to 0, or it can be less than or equal to 10. But that's actually not the case. I know it's counterintuitive, but what I want is both of these to be true in this case. Compound ifs. Now, if you're writing a program, you can use nested ifs, you can use compound ifs, whichever you prefer. Compound ifs can save you a lot of space. But, I mean, a lot of time nested ifs can do just the same, actual coding-wise. Just depends on what you're writing, what you're doing. But this right here is your basic rundown of compound ifs. Now again, if you're practice it, throw in a couple of other things, try Booleans, try doubles, try strings. Just be, string dot equals this, string dot equals that. And sometimes I'll have a question about the switch case. You can't really do a compound switch case. Well, I guess you could do a Boolean compound switch case. You could make a little method or program that could run through and return a true, false, or number depending. There are ways you could get it working, but honestly, just use ifs for that. This is one of the reasons ifs are used the most. Switch cases are great for simple things for the most part. A simple list of items that could possibly be true or false. Uh, but when you get to complex things like I have to check 10 different things at once, generally you're going to use an if, nested or compound probably, just depends on what you're doing. But there you go. And if you have any questions or issues, just let me know. And that is it.